So last time we looked at why we use percentages in the calculation of the price elasticity of demand. This time we'll take a look at why we use the midpoint as the starting point and why we use the absolute value. So let's go back to the demand curve and look at that behavioral change that we're trying to capture. So again, here's that original demand curve where we have a price decrease of $2.50. And then we have an increase in the quantity demanded of 20 units. And so part of the question here is, how big is that change? And we're talking about moving from, say, point 1 to point 2. But what if instead we talked about going from, say, point 2 to point 1? And so instead of talking about a price decrease, what if it was a price increase of $2.50? Then it would be a decrease of 20 units. You notice that the change here is exactly the same. It's $2.50 and it's 20 units. It's just whether we're moving from 1 to 2 or from 2 to 1. Well, would that change our measure of the price elasticity of demand? Well, let's take a look at what that would look like if we just use, say, standard percentages that you're probably familiar with, where we use the starting point as the denominator. So the price elasticity of demand, we could look at that as, remember, the change in quantity. And so that's 100 minus 80 all over 100 plus 80. Right? That's using the midpoint. But what happens if we, say, used 80 instead at the top? Well, that would be 100 minus 80 all over 80. In the denominator, we have the same thing with price. Remember, our original measure then said, we're going from $11.50 to starting at 14. And again, we use the midpoint here and divide it by 2. And then we have the absolute value, and then don't forget your order of operations. But again, what if instead of using that midpoint for the price, what if we used 11.5 and 14, and then used our starting point of 14? We're going to keep the absolute value for now. We'll talk about that in a little bit. So again, now, if we take a look at the result of this calculation, we see that in the numerator here, we have a gain of 20 units. So that's 20 all over 80. And then in the denominator, we have that decrease of 250 all over 14. Again, we're keeping the absolute value here. And from this, it's 0.25 all over minus 0.179. And if we do the result of that calculation, we get 1.4. So that's basically going from 1 to 2. We see that the elasticity of demand is equal to 1.4. But what would happen if instead of going from 1 to 2, we went from 2 to 1? We were talking about a price increase. Again, it's the same points on the demand curve, and it's the same number of cases that are gained. It's the $2.50 price change. What would change in this process? Well, really, instead of this denominator up here being 80, we need to change that to be 100. The denominator down here for the change in price, instead of being 14, is 11.5. And you'll notice we could also switch these. So this is now 80 minus 100, 11.5, 14 minus that, sort of from these. So really, we just need to kind of change the signs down here. If you went through that process and did that calculation, you would actually find that the elasticity of demand is now 0.92. And so what does that tell us? That tells us if we were going from 2 to 1, right, we were talking about a price increase. Now all of a sudden, the elasticity of demand is a whole lot smaller. It's 0.92 instead. And that poses a problem for us in some cases, thinking about this as really capturing a behavioral change. And so when we use the midpoint, what we see is kind of going back to this original function that we have here, that it doesn't change the result, right? Whether you switch these or not, you're going to end up with 100 plus 80 or 80 plus 100. Both of those are still 90. And so the denominator here won't change whether you're talking about an increase or a decrease. Now, the last part that we want to talk about is why do we use the absolute value in this formula? Well, you'll notice the result of the calculation sort of at this point before I use the absolute value, that result is always negative. But again, what are we capturing? We're capturing this price change and then how big the quantity demanded change is that results from that. And so something that's bigger, right, the bigger change here, right, that number is going to be larger. So if we say something's more elastic, what are we saying? We're saying that this change in quantity is going to be bigger. But there's a problem. What happens down here, the result of this thing's negative, so it's going to be a number that's more negative, right? It's further away from 0. And it just seems a little weird to say something's more elastic or the elasticity is bigger and to talk about that as a number that's really smaller. So we use the absolute value to give us a number that, say, 1.4 is actually bigger than 0.92. And so it would make sense to say 1.4 is more elastic or that the quantity changed is bigger as a result of that. So now that we have these three important pieces, right, we've talked about why do we measure things in percentage terms? And the big part of that is so that we don't have to worry about the units. Then we measure things using the midpoint. And why is that? Well, the midpoint helps us to not worry about the direction of change. And then lastly, we use the absolute value. And again, we use that so that the number just makes logical sense. Bigger numbers are more elastic. And we could certainly talk about reasons why we may want to use some of these or all of these. And sometimes you'll often see an elasticity that's reported in the negative. And that's perfectly fine, and that helps us remember that price and quantity are moving in opposite directions. But for now, we'll use the midpoint formula in this form.